Today we're going to be covering something that we kind of already know. Factoring standard form quadratic trinomials. What's the first type of factoring that we learned? To pull out the GCF. That's the first type of factoring that we learned. That's the first type of factoring you should always try. Okay, so this is not in your notes. Write this down right here in red. Write it down. Always start by trying to pull out the GCF. Sometimes there is no GCF to pull out, but if there is a GCF, pull that out. Factor it out. That way, your numbers are smaller, nicer, easier to work with. You have to pull out the GCF if you can. That was the first method of factoring you learned. That's the first factoring method you should try. So we also have these simple factoring quadratic trinomials when your a value is 1. That means that there's no number out here in the front. That's super easy. You just jump right into the answer format, factored form, and think what times what is negative 12, that if you combine together is negative 4. What times what is your c value, that if you combine together is your b value. Of course, when your a value is 1, that's the only time you could actually do this shortcut. And it might help you to make a list with the negative 12, like negative 1 times 12, negative 2 times 6, negative 3 times 4. And notice how I'm counting, right? 1 times what gives me 12? 2 times what? 3 times what? And that's about it. Those are all the possible ways of getting negative 12. Which pair of numbers combines together to give me a negative 4? That's right. The correct combo is positive 2 and negative 6. Now the thing is this. This negative 2 plus 6, that'll give me a positive 4. And that's the right number, but it's the wrong sign. So that means I have the right numbers, I just have the wrong signs. So change both of them to a positive 2 and to a negative 6. So that's a plus 2 and a minus 6. And that's your factored form, x plus 2, x minus 6. That's cake. And there's going to be 4 of those out of the 20 on next Friday's or next Wednesday's test. And of course, we have more complicated factoring methods. Like this one's ridiculous right here. It's a long, long process, right? When is this? When you want to factor a quadratic trinomial, but when your a value is not equal to 1, like if it were a 3, a 4, a 5, a 2, a 12, whatever number out here, you'd have to use this long multi-step process. Just to review, step 1 is to multiply a times c. You get an answer. Then you make a list for step 2. As a matter of fact, it doesn't say that right here. Let's do this. Let's zoom in and let's write down very small. Let's write make a list. Make a list. That's step 2 right there, making a list. What times what is that answer? That if you combine together gives you the b value. Okay, what times what is that answer that if you combine together gives you the b value? And the clearest way to see that is to make a list. Okay, and then step 3 is where it gets weird. You take your trinomial and convert it to a polynomial. How do you do that? You get that pair of numbers from step 2 and you rewrite your bx term as those 2 numbers, converting it from a trinomial to a polynomial, 4 terms. Why would we want 4 terms? To be able to factor by grouping, which is number 3. Okay, it is a long process. If you understand it, that's great. I will show you an alternative method in a little while, and the alternative method is down here, but we'll get to that in a little while. Right now, let's actually practice. Let's just put the notes to the side. Maybe you want to copy this down on the back side of your notes. What should you do here? I mean, this is going to be on your test next Wednesday. What should you do here? What could you do? What should you do first? Pull out the GCF. Always try to do that. You won't always be able to do that, but you always try to do that. So what could I pull out? 2. If I pull out a 2, what's left on the inside? B squared plus 5b plus 6. All right. Now, whenever you pull out a GCF, you're supposed to continue and look at the inside and see if you could keep going. Like maybe you forgot to pull out a b from all terms. Oh, there's no b here. Okay, you're safe there. But is there anything else? Is there anything else that you could do if we're just focusing on this blue quadratic trinomial that the a value is 1? You could actually continue factoring here, guys, right? Imagine that this 2 weren't there, and you just saw that blue quadratic trinomial. Wouldn't you set this up and put a b right there and a b right there? Right? Okay, so let's do that. What times what is the c value? 6. that if you add it together is 5. 2 and 3, right? I mean, the only way to get 6 is 1 times 6 or 2 times 3. That's it. Which pair of numbers works that if you combine gives you 5?
2 times 3.
2 times 3. So let's put a plus 2 right there and a plus 3 right there. And let's not forget about the original GCF 2 that we factored out. That belongs in the first part of our answer, so bring that down. Ladies and gentlemen, this is completely factored. This is what we call completely factoring. Yes, we pulled out a GCF of 2, but then we continued to factor, if possible, that is. We continue to factor right here by doing the shortcut B. What times what is C? That if you add together is B. Let's look at a different one. So on this one right here, you cannot pull out a GCF. You cannot. So we're kind of stuck with doing this method right here that says you factor this quadratic trinomial when your a value is not 1, it's 4. So I have to use these 4 steps. So step 1 is to multiply a times c. That's what I'm going to do. And I'm going to label my steps. Step 1, multiply a times c. What's the answer to a times c? What was that? Negative 12. Thank you very much. A is 4, c is negative 3, a times c is negative 12. Now step 2, if you read it on your slip of notes, is to make a list. You guys should have written down make a list of the multiples of this answer. So how could I get negative 12? I could do negative 1 times 12, negative 2 times 6, negative 3 times 4. And that's all the possible combos to get negative 12. Which pair of numbers combines together to give you the middle value 4?
2 and 6.
The negative 2 and the 6. That's good. So I am going to plug in that middle value, or not the middle value. I'm going to rewrite the middle value as these two terms. Okay? Converting my trinomial to a polynomial. That's the weird part of the steps right here. It says, step 3, get that pair of numbers from step 2, this pair of numbers right here, and rewrite your b. It should say bx. It should rewrite your bx term as those two numbers, negative 2x plus 6x. So we're going to rewrite the whole thing, but instead of 4x, I'm going to write it as negative 2x plus 6x. Check it out. Rewriting the whole thing. This is step 3. You have your 4x squared, and then I'm going to write my middle term 4x as the two terms from step 2, minus 2x plus 6x. Does that make sense? Now my final c value is minus 3, so I still need to write that minus 3 over here. Why would I change a trinomial to a polynomial?
So it's easier
to factor by grouping. To factor by grouping. Okay, so that's what step 4 says right here. Oh man, it got messed up. But yeah, step 4, factor by grouping. That's a 3-step process itself. There we go. Sorry about that. So let's factor by grouping. Step 1 is to make space between the two groups. The first two terms separated from the second two terms. After that, you want to factor something out of the first group. What could you pull out of the first group?
X.
An x and a 2. You're going to pull out a 2x. That's your GCF. What would be left over on the inside? 2x and
1.
minus 1, right? If you say 2x times 2x, that'll get you the 4x squared. 2x times what will get you a minus 2x? You need the minus 1 right there. Now let's look at the second group. What could I pull out of the second group?
3.
A 3, a positive 3. What would be left over on the inside? A 2x minus 1. And this is where you take a step back, you put some exaggerated parentheses, you pull out that common binomial of 2x minus 1, you just pull it out to the front, and then you ask yourself, what's left over? Well, there's a 2x left over, and there's also a positive 3 left over. Again, I'm just leaving those exaggerated parentheses to show you that you used to have a 2x minus 1 there and a 2x minus 1 there, and now that common binomial is missing in both. So to write my answer on the answer column, I'm going to write it with the correct size parentheses. 2x minus 1 times 2x plus 3. That's my answer. Yay?
Yay.
Okay. So, do you understand that method?
Yeah.
Do you guys want a somewhat of a shortcut?
No.
No? You can. Yeah. You could be like, I don't want to learn anything.
Like this, and when I hear the shortcut, it gets me off.
Okay. So if you're good with this, stick with this, right? If you're good with this, stick with this. But the shortcut is really, let me just show it to you, yeah? Check it out. So I've deleted the work, and we're going to use this alternative method at the bottom part of your notes. Step 1 is the same step 1, right? Multiply A times C. We get negative 12. Step 2 is the same step 2. Think of the multiples of negative 12. Negative 1 times 12, negative 2 times 6, negative 3 times 4. Which pair of numbers combines together to give you the middle value 4? The negative 2 and 6, right? Same exact 2 steps. So here's the shortcut. Step 3 and 4 are different. Normally, I would say convert your trinomial to a polynomial so you could factor by grouping. If you're cool with that, great. But right here it says step 3, plug in that pair of numbers from step 2 into this answer format. Now that's really weird. The answer format is AX times AX. So what is A?
4x.
A is 4, B is 4, C is negative 3, right? So I am going to actually write a 4 and an x right there. And a 4 and an x right there. If this would have been 5x squared, it would be a 5x and a 5x. If it would have been a 3x squared, it would be a 3x and a 3x. Now we know that this is wrong, right? We know that this is wrong. Why? Because 4x times 4x is 16x squared, not 4x squared. So we need to modify this later, but right now, following the shortcut steps, you plug it into AX, there it is, there it is. And we take the pair of numbers from step 2 and you plug it into this answer format. So what pair of numbers we have? We have a negative 2 and a 6. So let's take that negative 2 and plug it in right there, and the 6 and plug it in right there. It looks like that's your factored form answer, but we know it's not because then we already said 4x times 4x is not 4x squared. So here's the last magical weird step. Now, why do I say magical weird step? Step 4 says reduce each binomial. It's not even a fraction, right? It's not even a fraction. So I'm just saying reduce because it's kind of like dividing both terms by whatever you can, by the GCF. So if you look at your 2 terms right here, what could you divide this by? By a 2. So if I divide by 2, what will I get? A 2x minus 1. If I divide this other one, what could I divide the other one by? By 2. If I divide the other one by 2, what do I get? A 2x plus 3. And ladies and gentlemen, that's the answer. So if you want to avoid factoring by grouping, this is an alternative method. I mean, I like factoring by grouping because it's always consistent and it makes sense. This guy right here is kind of weird. Like I said, magical step 4, reduce, right? Divide this by 2, divide this by 2. It's kind of weird, but it'll still give you the same exact answer. Check it out. Let me, here's all the work we did on the previous one, and you could compare it to the work we did on this one. So obviously it's a little bit less work, it's a little faster. That's why I call it an alternative shortcut. If you like factoring by grouping, go for it. If you want to try this new method, go for it. Maybe you don't want to get confused with so many methods. It's totally up to you. Let's try another. Here we go. Let's try this one right here. What could we do here? Could we pull out a GCF? No. So we need to jump right in to our notes, right? Step 1, it doesn't matter which method you choose, the factoring by grouping or the alternative shortcut, you have the same first 2 steps anyway. Step 1, A times C. What do I get?
18.
Negative 18. Okay, step 2, make a list. Everybody should have make a list, right? How do I get negative 18? Well, I got negative 1 times 18, negative 2 times 9, negative 3 times 6. Which pair of numbers combines together to give us the middle value B? Negative 2 and 9, that's right. And you don't even have to change signs, right? You don't even have to change signs. If you add negative 2 and 9, it really does give you that middle value 7. So here's the crossroads. What do you choose? Do you want to do factoring by grouping, by changing the 3 terms into 4 terms? Or do you want to practice the shortcut again with that magical 4th step? You know what? Let me go with the shortcut one more time just so it'll stick, right? And then we'll do grouping. You know what? We'll do both. But check this out. Let's do the shortcut here. Step 3 is to plug it into your factored form answer format. But instead of m times m, what do I need to put here? AX, which is what? 6m. 6m and 6m. Now, what do I put right here and right here? The minus 2 and the plus 9. Minus 2 and plus 9. And then my step 4, see right here, step 4, reduce each binomial and divide it by dividing it by its GCF. So just look at the first binomial. What could you divide both by? 2. What do you get if you divide both of those by 2? 3m minus 1. How about the second group? What could you reduce by? 3. What do you get? 2m plus 3. Now, like I said, that's the answer. The only reason why I kind of don't like this is because if somebody asks me, well, why do you divide right here by 2 and right here by 3? I don't know. I mean, I know it's because I have to get rid of this situation that 6m times 6m, that would give me 36m squared. So, of course, I need to change these guys. And it happens to be that you divide by those GCFs. But if you don't like that method, we could go with the other method. You would still do step 1 and 2 exactly the same. The only difference is when you rewrite your trinomial into a polynomial, you would have 6m squared. Here's the other method, right? We already finished it. If you like that shortcut, go for it. Here's the other method. Instead of 7m, I could rewrite it as a minus 2m plus 9m, and then put that minus 3 at the very end. And then you could rewrite it by separating it into 2 groups. And then factor something out of the first group. What could you factor out of the first group? A 2 and an m. And what's left over on the inside? 3m minus 1. Okay, what could you factor out of the second group? A positive 3. What's left over on the inside? 3m minus 1. And then you factor that common binomial out of the whole thing. So you have the common binomial of 3m minus 1 out here. And what's left over on the inside? The 2m. And the plus 3 is also left over. So there's your answer. 3m minus 1 times 2m plus 3. It's the same exact answer. It just takes a couple of seconds longer than the shortcut. A little more work to show. What do you think? Shortcut? If you like the long method, go for it. Factoring by grouping. What's the first thing to do here? Multiply 8 times 48. That's going to be a huge number. Factor out the GCF, right? That makes everything easier. So let's pull out what? A 4. What's left over on the inside? 2z squared plus what? 5z minus what? 12. So we factored out the GCF 4. Now we could look at the inside of the parentheses, which is a quadratic trinomial, but the a value is not 1. I wish it were 1. I could use a shortcut. But because it's not 1, I have to either pick factoring by grouping or that shortcut method that I just showed you. Shortcut. Either way, step 1 and 2 are the same. Step 1 is to multiply a times c. So we are going to ignore the 4 for a little while. What is a times c? Negative 24. And then step 2 is to think of the multiples of negative 24. That'll combine together to give you the middle value, which happens to be 5. Not 20, but 5. Don't go back to the original. We're working on the inside of the parentheses here. So let's make a list. Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. Those are all the possible ways of multiplying to get 24. Which pair of numbers combines together to give us a positive 5? Negative 3 and positive 8. Okay, so now, do we want to go factoring by grouping? Or we want to go shortcut? Shortcut. I want to go shortcut. Answer format. I need to put my AX term in each one of those. So what belongs right here and right here? Don't go back to the original. We're working on this guy, right? 2z. So don't make the mistake of going back to the original. We have a 2z here and a 2z there. And now what do we do with these numbers? Put them right in here. So you have a minus 3 plus 8. And the final fourth weird step of this alternative shortcut is to what? Reduce it, right? Divide by whatever possible. So do you have a GCF? Like, is there a 2 and a 2 in common? Could you reduce both by 2? Could you reduce both by 3? You can't do anything, so I'm just going to leave it. So it's 2z minus 3. How about the second one? Could you reduce by anything? What does it reduce down to?
4.
Reduce by 2, what do you get? Z plus 4. We're done. Oh, wait. I totally forgot. I forgot about this 4. This 4 right here. So let's take that 4 and we need to put it out here in front of our answer. So the final answer is 4 parentheses 2z minus 3, close parentheses, open parentheses, z plus 4. So you have your slip of notes. You should be able to do all of the front side of WSP 8.7. We're going to do the odd ones on that worksheet.